Hey,
Hey, how's it going?
oh, it's good. It's good. Good to be back.
Good to hear it.
Uh, Hi, it's nice to meet you.
It's good to meet you as well. All right, I'm gonna see if I can make, let's see. Dun, 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 dun. All right. John, are you able to hear me? I think John might still be getting his audio connected. So one of my kids this afternoon was playing with the hose and yanked on it and broke the fitting where the hose connects to other things. So I've turned off the main water, but I am going to need to go run up and try to get that to a point where we can turn on the rest of the water pressure in the house again. So I think I was able to make John Karsten's, actually, maybe I'll go ahead and make Todd the host real quick. And hey, Todd, how's it going?
I'm well. How are you?
Pretty good. I'm gonna swap over to make you host. They did switch up the privacy settings so that anyone new joining the meetup will show up as a participant, but their video and audio doesn't work until you admit them. One of my kids broke a pipe that I need to go attend to. Luckily, it's in the yard and it's not gushing water at the moment, but I need to get that a little bit settled. So hopefully, if I get that settled relatively quickly, I can jump back. I actually have a project I've been working on recently for my golf cart that I can share a little bit about, but I'm going to run out here for a minute.
Awesome.
All right, well, hopefully I'm back soon and I can talk more. I'll leave myself joined, but just muted. It's good to see everyone and hopefully not for the last time tonight.
Good luck.
All right. Hello, everybody.
Hello.
I'm going to hang
Hello.
tight till everybody joins. Hey, Alex. Where are you calling in from, Alex?
Just a little north of Seattle.
Oh, okay. Welcome.
Thank you. Yeah, I didn't notice that these meetings were going until I kind of dug into a kind of back alley of the website, I guess. So cool to see this is happening.
Cool. Well, I'm glad you found us. Konnichiwa, Osamu-san.
こんにちは。It's nice to meet you. My name is Osamu Yamauchi. I'm very, very glad to you.
Arigato.
Thank you.
Okay. So Michael's going to show us some of his go-kart stuff. I can show off a project I've been working on. Does anybody else have anything they want to show off or talk about or ask questions?
Not really. I've been struggling with Phoenix this month, so nothing really to show, but
I've got probably a question. Some of us folks in the Seattle Elixir meetup are working on a little project, and we've got Chameleon as one of the dependencies, and looks like you might be the person to talk to, maybe. So we just noticed a bug when trying to do some of the type checking, and I sent up a PR, and I'm just wondering what the best way to move forward with that is, if you're still maintaining it or don't have time to.
No, when did you send up the PR?
Oh, it might have been a week or two ago, something like that.
Okay, I'll check it out. Let me write it down so I don't forget.
Cool.
I just did not get the notification.
No problem. We're running off a fork right now, so it's not necessarily blocking us, but yeah, just wanted to make sure you knew it was there.
Okay, thanks. I appreciate it.
I guess I
Konnichiwa,
could.
Hideki-sensei.
Hi. Good morning. Oh, so good evening in America. Hi. Hi. Do you know me? Oh, can you hear me? Okay.
Yeah, we can hear you.
Yeah, okay. Okay. Yep. Oh, is it a time to introduce me?
Sure, you can introduce yourself.
Yeah.
Go ahead.
Yeah. Sorry. My name is Hideki Takase from Japan, and I am a researcher at the university. And so my research topic is embedded systems and real-time systems. So I am curious about nerves, and I'm writing a proposal to NervesConf about real-time performance for nerves. So please check my proposal, and I wish to attend an NervesConf physically. So that's all.
Okay, thank you. Good luck. So for anybody who's not aware, NervesConf is happening this year in November, October? Now I forget.
October, right? Yeah.
All right, okay. So it's the inaugural NervesConf. So hopefully everything will be safe by then. We can actually go to meetups and conferences.
Hi everyone.
Hello.
Hello, my name is Aldebaran Alonso. I think I met some of you back then, like a year ago, like in Lone Star Elixir Conf. I talk about talking to a PLCs. I don't know if someone remembers.
Where are you from?
I'm from Mexico.
From Monterrey?
Yeah.
Ah, Viva las Reales.
Sorry?
Viva las Reales. Right? Or Leones.
Right.
That's your football club, right? The Reales.
Yeah, León. Tigres.
Tigres.
Tigers.
Okay.
Tigers. Yeah. And well, I would like to share with you some project that we have been working. So it's more like with industrial protocols and something like that. If if you let me the time for speak a little bit about it.
Sure. Why don't we wait 2 minutes and then we'll get started in earnest and you can kick us off if you're ready.
Okay, well, I don't have like a presentation. It's just like a repo
Okay.
that you can take a look about it, and it's way an early project, but I would like if some of any thoughts about or opinions about it, and and I will talk about some problems that I have, and well, that kind of things. So just tell me when you are ready.
Hello, John. Whoa, you got your COVID-19 haircut.
Yes, I do. Nice and long.
Nice. Do you have anything that you want to share tonight or talk about?
It's a great question. To which my answer is no.
Okay.
I don't have anything prepared, if that's what you're asking.
Yeah, more or less. All right, that's fine.
So
Okay.
I'm assuming Mike's the one that had stuff, and now he's run off to fix his water.
Yeah, Mike has got something. I have something I can show too. And we have one more presenter. So we can start with that. Mi amigo desde Mexico, are you ready?
Yeah.
All right. Do you want to share your screen?
Well, actually, let me
Do
desktop
you want me to
share.
start? Do you want me to go first, or are you ready?
Okay, yeah. I'm sharing my screen. Do you see it?
Yes, sir.
Okay, well, first of all, let me introduce myself. I'm Aldebaran Alonso. I'm mechatronic engineer at Valiant. Yes, something like this. This is our organization in GitHub, Valiant. There are a lot of repos, open source that we are um, sharing. One of it, um, well, as I say, I was mechatronic and I work more with hardware and embedded systems and so on. So some of my task is to use industrial protocols and make wrappers and that kind of things. So one protocol that I need to implement or use is OPC UA. However, I don't have any knowledge about if there is an already wrapper or something that I can use to easily implement that technology, that protocol. So we make this repo, OPEX 62541. Basically, this is a wrapper of another repository that is called Open 621 41. Yeah, that project. Well, this repo is a library from uh, with a whole implementation of OPC UA in C. So basically, the wrapper that I was talking about makes it's a library like circuit UART that uses ports to communicate with low level language as is C. Um, However, as you see before, the C library, it's a huge library, like over 6,000 commits, and is a huge amount of information that I need to grab. So, well, I am trying to do it my best, and here is the wrapper in the C backend as I call. So, well, basically this is whole C code using Erlang library to talk to C and using the code, and well, basically that's the project. However, uh, in the Elixir part, which is this part, I use well, the open project, the open C library can implement the client behavior and the server behavior. So I try to make it both behaviors to be to be made in Elixir. So um, basically, this is the work that I have done. However, I don't know if any of you guys are familiar on how is implemented circuit UART. Basically, you are sending messages to the port, to the port behavior in Elixir that talks to C, and C sends the response back to the port, and you use that message. However, this is kind of a synchronous communication. However, to make the server behavior, you need to manage asynchronous communication, because maybe some other OPC client sends a write command to the server, and well, the C backend must send the request to the Elixir application. So that application can do something, I don't know, print it or something, no? So that's the problem that I am trying to solve, how to make things synchronous. Well, talking about how I make the Elixir code, basically it's against server code, in which we use normal calls, and then you have, I think, mm, well, I have a little bit of mess here, because some functions of the server and the clients are the same, so I group them in a common module. So this can be, well, I can write less code. But well, this is the functions that share both the servers and the client. And here is when the magic occurs. Um, this part talks to a port, and then waits for a receive for a message from C code, then parser, and send it back to every handle call that has called the port. Basically, uh, the other thing that I made is the, oh well, I haven't here. Mm, oh, here. This chunk of code basically does a asynchronous catch from the C code. Here, basically parsers the data and show it as warn. However, uh, here I can put to, I don't know, send to another process the data more, I don't know, Elixir coded. And however, I am looking for another way of doing this. This I think is kind of messy. However, maybe using, oh well, mm, I have been looking for other wrappers that made the thing that I think that is more clean. Some of this is this repo that is called WebSockets, which is a library that uses WebSocket basically. And well, basically my goal is um, to make something like this, in which I can't use the, I don't know, OPC UA server. The user defines the start link and a custom handle. Well, that's what I want to do, but I don't know how to do it itself. Um, that the user, to be able to make his own handle, I don't know, handle write function, in which the state, well, can be easy to use this state with this kind of function. Mm, I dig a little in this repo and I conclude that they use the so-called special process in OTP, which is like doing their own implemented Gen server, like step by step. But I think that is too many work. I don't know if someone knows or have some examples that do something like that I want to do. It will be a lot of helpful. Well, basically that's it. I don't know if anyone has questions, opinions. I will send this link in order you to maybe you can check it out. Oh, how did I do that? Well, I think, oh, here, more chat. Here is the link. If everyone wants to see it. So, well, that's it.
Okay, thank you. I have a question.
Yeah.
What was the impetus for this? Like, what are you communicating with that uses this protocol?
Well, basically, in industry, they use a lot of UPC UI servers or devices for running sensors, production lines. I don't know. It's like concentration data, you know. Uh, well, we we have seen that some industries use them as a data concentration center. So if we are trying to do some IoT stuff or industrial IoT stuff, we need to pull that data in order to, or backwards, if we need to export data from us to our clients, we need to talk in the same language. Well, that's the idea. I don't know if I've been clear with this.
Yeah, no, that's clear. I wasn't familiar with it at all. So, I don't know, John or Hideki Sensei, have you worked with this? Are you familiar with this protocol?
Sorry, I don't know this protocol, but my friends in Japan, uh, my friends in Japan is expert about OPC and PLC line. So I will share this repository to my friend.
Cool.
Yeah.
Thank you.
Okay, thank you. That's great. I will stop sharing.
Okay. Well, thank you for that. Something to look into, I guess. So I am
Thank
going
you.
to share what I have been working on, which I of course didn't get as far on as I had hoped for this meeting. But that's not unusual. Okay. If you can't see my screen, say something right now. Okay, good. So this project that I've been working on was inspired by another member of this group. So I was talking to him one day on Zoom, and he was telling me about this thing he was working on with nerves. And it's similar but different from this project. So it's called Network Monitor. And let me bump up the screen size a little. And the idea is it's a nerves application that will check your internet connectivity on your network and sort of just monitor it for you and let you know what the status of it is. So there's don't let these pictures fool you. One of these is a red LED, one of these is yellow, and one of these is green. And so based on either packets being dropped or latency increasing, your network might go from green to yellow, or if you're dropping 100% of the packets, it will go into its red status, let you know that something's wrong. And so that's actually very similar to the project that Aaron showed me that he was working on. But I decided to go one step further, and this box over here is a relay. And so what I have it doing is I have a power cord that's my router is plugged into that's connected to this relay. And the idea being that once it gets into its red state, that I'll restart the router automatically. And so that's what it does today. I think one thing I'm going to add in the future is to have it just cycle the power maybe daily, like in a very off hour, like 4 a.m. or something every day, just to make sure that my router is being cycled regularly so that it's working at top performance. And so yeah, it's just basically a Pi 0 single relay and 3 LEDs. And I think that's it for this. So it's pretty inexpensive in general. I'll show you the code. If anybody has any questions along the way, just jump in.
Todd, are you going to be able to demonstrate this for us live on the call?
Unfortunately not. So what I did do is I ordered a 3D printer a couple weeks ago, and I was like, cool, I'm going to model a nice case for this thing so I can plug it in and have it look nice. And I haven't gotten around to modeling any of that stuff yet. So I did model one box, and it didn't turn out exactly how I wanted it to. So I gave up and cried. So hopefully at some point soon, I will. I guarantee it works though. I have tested it. I guarantee that it works. It's in this little contraption right now. So you'll have to use your imagination. Oh. Okay. Welcome, Ganesh. We're right in the middle of presentations. So we'll get to your introduction shortly. Okay, cool. So this is there's not a lot to this application. There's not a lot of components or anything. So the supervision tree is pretty simple. So it's got a main supervisor and 2 processes going. We show the ping server here. Let me bump up the font a little bit. Try to bump up the font. There we go. And so it pings the internets, which if you don't spell it this way, you're doing it wrong. The internets on an interval to verify the connection. So you can see it's like a pretty standard gen server, like pretty basic. Its ping interval is set in the config. And so I was playing around with different timing on that. And in this case, it calls out to fping. So fping is a utility that doesn't come on the Nerves base install. So I did have to add it, which came with its own little troubleshooting error, which I couldn't figure out, but Franklin was able to figure out, which was it was expecting a certain file to exist that it was just touching. Didn't really need it to do anything, but it was crashing because this etc directory didn't exist. So I added that. So basically, yeah, it just calls fping. In this case, I'm using this 888, which is the Google DNS server, the Open DNS server, just because I figured it's going to give me the fewest false positives, I guess. I assume that the Google DNS server is probably monitored pretty heavily, and the latency is usually pretty low. If you're going to run a DNS server, you want it to be up all the time, and you want its latency to be very low. So that's why I went with that. And so just to be clear, like fping, these arguments, so this -c is a count, and then 3. So if you ever hit ping, and you just notice it just keeps running forever, Not the Nerves toolshed version, but the regular version. So this just runs it 3 times. So I grab the response, parse it out, which this is the pattern that I'm essentially looking for. And so this is a regex with captures. So it's capturing the first group as time, and then loss. So the last group is packet loss. And so yeah, essentially it just goes out, does that fping, parses the response to get the numbers that it needs, calculates the results, which is like how many packets did I send out, and then how many packets did I get back, and then that's essentially like my packet loss ratio. And yeah, so that is that one. I'll show you the GPIO Gen server, which is just really basic. If you've done nerve stuff, I assume you've done something just like this. It's just basically emitting the pins. So in this case, it's opening up these 4 pins at the configs that I have, and just making sure that they are opened. And so let me see. So the ping server eventually, like its goal is to output to the display and let you know what the status is. And so it goes to display light up here, which you can see it just takes those 3 values, the attempts, the packet loss, and then the total time spent. And then based on those measurements, it's going to respond in one of 4 ways. And so these are status is just calculated by pattern matches. So this is like 100% packet loss. That's an alert. If the packet loss is greater than 0, we go into warning. If the time, like the total time to do the 3 calls, is greater than 2.5 seconds, we go into warning mode. If something very unusual that we can't really identify happens, just go into an unknown state. So in my case, unknown state will light up all 3 lights, and otherwise it's considered okay. And yeah, you could just kind of see like this is the unknown. It's turning on all 3 lights. This one's turning on the green lights. And then the last thing that ping server does is send its data to the power module. So it does the lights, and then it does the power, which is the relay. And so it calls this maybe restart at the end and sends data. The only condition under which I'm restarting right now is if the packet loss hits 100%. So if so, it goes to cycle. So cycle will power off. So in this case, the relay is in a normally connected state, which means that given no signal, it's going to assume the circuit is closed. So it's going to get power. So if the nerves device like goes crazy, or if like the Pi itself loses power, or the card goes bad or something, the relay is going to be in its on state. So it's not going to turn off my modem. Its default state is going to be on. So in this case, it's flipping that. So it's actually sending it a signal, telling it to open up that circuit, and waits 15 seconds and then powers it back on. So yeah, like I guess I kind of explained that before. It's just going to cycle the power in an attempt to get the modem itself into a good state. As you know, if you've watched the IT crowd, first step is turn it off and then turn it back on. And so yeah, I think my next steps, besides building a case for it, is going to be to add that that scheduler so that it'll automatically cycle the power in the middle of the night every night. And I think that's it, unless maybe have it send me a text message if it goes into an alert state, just because where my modem is not someplace that I walk past a whole lot. So if the lights are going crazy, I probably won't see it. So, or if anybody has any other ideas. And that's it. Any questions, comments, praise?
So has this already cycled? Has it already happened before?
Has it
Like
gone
it-
into a bad state?
Yeah, has it gone into a bad state and actually triggered the cycle?
Just when I was testing.
Yeah,
I'm
this
curious-
is. Oh,
Sorry,
go ahead. Go ahead.
Okay. I'm curious why farm out to fping versus opening like an ICMP socket from inside Elixir itself?
So ICMP is difficult in Elixir. So there is I literally didn't see any library that truly used ICMP to do this. So there's a couple of utilities that use GenTCP to do this, but they're just a real pain in the butt. I forget what the
Gotcha.
there is a library that does this, but it was like it just was a huge foray. And and another reason is just that like when I was testing this out on my host machine, I was using fping, and so I got the regex that it outputs and everything, and had it all working. And so then I was already sort of mentally committed to that idea.
Cool. Gotcha.
Not a good reason.
It was the quickest path to implementation. That's a perfectly good reason.
Yeah, I kind of like fping. I actually think it's pretty cool, and like it uses ICMP as far as I know, but it had much less code for me to implement to just make a system call out to that.
Cool.
And it was pretty easily available in build root. So okay.
Yeah, this is really cool. I could have used this many times. I remember there was one time my wife called me from work, and I was trying to explain how to, she didn't have an internet connection. I was trying to explain where the router was and how to turn it on and off. So yeah, this would have been really cool. And another comment, what do you think about, aren't there like some smart relays or switches? In other words, like or I don't know if it's like you, my router's in the basement. It's really out of sight. Be nice to have the display in one place and the switch to turn it on and off in another place. But I don't even know if that would work if your internet is down. So.
Yeah, actually, that's a really good idea. And I did not think of it. I'm not sure why I went immediately to the relay, but if you use something like Grizzly, you can get those smart plugs off Amazon for like $5.
Cool.
And you could totally do that using the Z-Wave protocol. So it doesn't require internet or anything like that.
You could also put anything to trigger the relay, because you can power the relay from the same power source for the router, and then all you have to do is interrupt and add the trigger. And so you could do like a radio signal, just a little radio receiver, which is all the Z-Wave things do. But any megahertz or kilohertz receiver, dump it on a relay, and then have like an all-inclusive module there.
Yeah, I actually like that idea a lot, Mark. That's I might scrap this and go with that.
No.
I have a
Yeah. Well, anyway, this is cool. This is great. This is something useful. So yeah, this is good.
Todd, I missed the beginning of this. You mentioned like trying to set up some sort of notification. If you're ping, like, do you have an alternate route to send that data for the notification? Because if the router is seeing ping, like if it's dropping all your ping packets, then are you going to be able to send the notification? I don't know. I hadn't thought through that at all. I'm just wondering if you have any ideas.
Yeah, right. Like obviously I wouldn't be able to send a text over a web API. So
You could have like a dead man switch.
what's a dead
Have
man
it
switch?
like make a HTTP call out to something in AWS LAN and like a Lambda function, and if that doesn't fire, after 10 minutes, then send you a message.
Oh, right. Dead man switch, like on a train.
Oh, I guess if you're doing that, you could also do a thing where like the device just keeps a WebSocket open and it was just, doing Phoenix pings. And then when you see the socket drop, that would be like, oh, that connection went away. Obviously the device is offline, which means my router is offline. Although then if the Pi card goes bad, you also lose that. And
Yeah.
I guess that's true for the dead man switch as well, right?
Yeah, if the dead man switch is on an external network though, I feel like that's a pretty good idea up until something goes wrong and it sends me 400 text messages.
You'd have
Rate
to
limit it.
You'd have to make that dead man switch a little bit smart. And now you're talking about like a 2-part project instead of a 1-part project. Maybe diminishing returns kicks in there. No,
the whole point that this meetup group exists is for totally impractical projects, Michael.
I'm not going to argue that.
None of us would be here if that wasn't the case. So, yes, these are very good ideas. Manuel, I like that idea about the deadman switch. And Mark, I really like the idea of using a smart plug so that I can actually see the light when this happens.
Yeah, I'm sorry. I don't see a Manuel here. There's an Amy though.
Oh, Amy, sorry. Hi, I dead named you, Manuel.
Yeah, there's an explanation for that. My wife was doing prenatal yoga, and I didn't want them thinking Manuel was signing into prenatal yoga, so changed the name.
Sure. Okay, cool. I guess.
Oh, one more question, Todd. So do you like reset your modem and router, or your modem and router in the same box, or?
Yeah. So my modem and my router from CenturyLink are in the same.
Oh, okay.
Are the same thing.
Okay.
I have I have a mesh network that's set up, but I don't really restart those very often. Those actually seem to be fine.
Yeah, my modem and router is separate. Usually it's the router that's the problem that needs to be reset, but I'm trying to think if there was a case when they both needed. I guess the safest would just be to turn everything off and on.
Yeah.
For me. Yeah.
Yeah, no, I think that's what I would do.
Yeah.
Todd, just one thing about the dead man switch, thinking about it, it'd be kind of funny, but the 0.001% chance that something in AWS goes down, it would end up cycling your home network. If you're running an AWS and they have the 5 nines of uptime, just be funny that it would be taking down your network as it cycles.
Yeah, like I have a hard dependency on AWS.
Yeah.
I also hear Mike's like real into Bluetooth and BLE lately. You could just do a local notification straight to your phone.
I was really into it until it was hard. And then I got really into alternative implementations.
Yeah.
Well, that's a fantastic segue, Michael. Why don't you tell us what you've been working on?
All right, I'll give it a try. So it's very much a work in progress, and I don't have a lot of pictures and stuff to share yet. But basically last year I got for free an old 1950s golf cart from a neighbor, and it actually fell off of a cliff in the 1950s, or rolled off of a cliff. And so he got it for free, and now all these years later he gave it to me. And last summer we took out the old sealed lead acid batteries, we put in a lithium ion pack, had lots of fun with it. And then this year I've been doing a couple of things. It had an old resistive speed controller that would change the voltage going to the motor. That's how it would vary the power, but that means you're throwing away a lot of power just into heat. So I replaced that with a pulse width modulation speed controller that uses MOSFETs. And so I got that installed, and then I really wanted to have something to monitor the level of the battery, because I didn't have, like basically whenever we would drive around, and I'm never sure exactly how much range I have, and I don't want to let those lithium ion batteries go too low. And so every once in a while we would just stop, and I would have my multimeter with us wherever we went, and I would stop and get off, and I would check, and I had left a balance charge lead at the end like available so that I could easily check it and plug it into the charger. But anyway, obviously there are many available products that for less than $5 can watch the battery voltage and give it to you on LCD display, but that's no fun. So so I'm starting a NERVS project, and essentially it's 3 major components. So there is first there's a little DC converter, DC to DC, that steps down the 36 volts power from the battery down to 5 volts, and it keeps that, you know, plus or minus 0.1 volt. And so that'll kind of power the whole project. Secondly, I have a analog to digital converter. I'm using an ADS1115, which is just like a standard TI chip, and Adafruit sells them as little breakout boards so that they're easy to work with. And that will tell you in an analog signal, right, something between 0 volts and some reference voltage, how far in between those two you are. And it does it with 16 bits of precision, which is pretty good. The one downside is that it only takes up to 5 volts as its reference voltage. And so it can't measure up to 36 volts. So then I am doing a little bit of soldering, and I made my own little voltage divider with 2 different sized resistors, and I'm measuring the voltage across the smaller of the 2 resistors. And then I do have to do a little conversion back the other way. So I can share a little bit of kind of the code so far. And hopefully I got it all together on a breadboard, and then I'll be getting it back together with like actually soldering it together, and I'll share some pictures of that once it gets going. But let me share this real quick. So this ends up being pretty simplistic. So I wanted, at one point I was gonna just do this as a scenic project and have a monitor, like a little screen, touch screen mounted on the cart. But the only good place to mount it was really far away from the batteries and everything, and I'd have to run a power cable under. And on top of that, I thought, you know, there's some other cool things I'd like to do, like sort of like unlock it from my phone. So instead of having like a key to turn on and off the golf cart, like have a remote unlock and a remote lock, and a few things like that, again, in the spirit of over engineering. So, so what I decided to do is I'm using, well, I started with the Raspberry Pi Zero W, and shout out to John Karstens. I used NERVS Pack. Where is it? This one. NERVS Pack includes VintageNet, and I was able pretty easily, here in my target config, I was able just to say, hey, just boot up the wireless version. And in my application, when I'm booting up, I just tell it to go into access point mode and set some static IP configuration. And by the way, the README docs on VintageNet were amazing. Like all the common use cases, they just have little snippets of like, oh, if you need to do this, here's just an example of exactly the config you need. So this really took almost no work at all. And so right now I'm just starting it up with no pass key or anything like that on it, just a totally accessible access point, which is super secure. And so I'll boot that up. It opens that up, and then I want to eventually maybe switch this back out to like a Poncho project so that these two live side by side. But for now, since I had already started the project, I just added in a Phoenix app under the vendor directory, and I depend on it just like I would in a Poncho project, right, using that path. So right here, I say, oh, I depend on the dash project, and it lives under vendor dash. And then inside of like the firmware project, the only thing that starts up is a battery monitor. The battery monitor, again, very similar to the concepts that Todd was showing, but maybe even a bit simpler. All it does is when you start it, it builds this little battery struct. Well, I guess I won't do side by side. It gets to be a bit much. But the battery module really just encapsulates a little bit of the details about like converting that smaller voltage, converting the 16-bit number into like what was my measured voltage, and then converting that back into like, okay, so what am I inferring the actual battery voltage to be? So it encapsulates a little bit of that, and it also, the struct holds onto a reference to my I2C bus so that I know how to communicate with it. So, so when the battery monitor starts up, it creates one of these little structs, and then it says, okay, and it sets a timeout of 500 milliseconds. And every time that timeout gets hit and it sends itself the timeout message, then I just say, hey, what's the current battery voltage? I do a phoenix.pubsub.broadcast. This is the only place in which the two software pieces interact with each other. So the whole reason I depend on the Dash project is just so that it gets included in the release and so that I can call this broadcast function. And all I do is say, hey, here's my currently measured voltage. And then inside of the Dash project, I just used, because it was all done recently, I just did the dash live argument for the Phoenix generator that exists now, which kind of gets you up and running with LiveView very easily. And so that one then just has, let's see, the user socket. What does this actually do? Oh, that's right. I'm not using a socket since it's LiveView. I'm just using this. So I took basically just like the standard hero page that ships with Phoenix. And all I did is remove a bunch of stuff and change one CSS thing so that it keeps a dark background by default. And then all I do is I catch those voltage signals. So whenever this thing mounts, I subscribe to that dash pub sub voltage topic. And when I receive messages with that voltage tuple, I format that to 1 decimal precision and then turn that into a string. And all I do is assign that voltage as my assign, and everything else is Phoenix LiveView. And I don't really have to think about that. So got this all up and running once. And let's see, I'll actually, I think I should be able to boot this. Phoenix.server. And open up localhost 4000. And it won't show me, well, let's see, I'll put this into like simulate a mobile device real quick. And then if I switch my share, oh, you share this thing. So it just, it renders a little thing like this. Oops. Renders this little thing. And this is just for my own reference. I'm reminding myself here at the bottom, like, hey, it should be hopefully between 32 and 42 volts most of the time. And then if in my terminal, if I just do the phoenix.pubsub.broadcast dash.pubsub voltage, and I'll just say like 38.7 something. If I publish that, then obviously it just updates, right? So, so I got this all hooked up, and hopefully I'll write a blog post here pretty soon about it. It ended up not really taking that much configuration. I would love to hear other ideas that people might have about, you know, basically I wanted to do the least amount of like wireless stuff myself that I could, but like whenever I drive somewhere on the golf cart with my kids, it's never in a Wi-Fi range. Like that's like literally the point of going on the golf cart is to be outside of the Wi-Fi range of my house. And so I just wasn't sure what other good things are available. I still think the Scenic project is probably would be a good direction to go with this. And really running wires for like 8 feet is not that big of a deal. So I could run that and just do it as a Scenic project, and then maybe just use like a pin for unlocking or things like that. So lots of fun places to go with this, but mainly just trying to have fun with a project again that like it's hands-on for my kids. It's fun for me to do, and And we do actually use it a good amount for cruising around the neighborhood and driving to parks and stuff like that.
So what kind of runtime do you have with this golf cart so far?
We've never run it out of battery in one run. So I generally charge it about once every 3 times we use it. And we usually will drive for like 20 to 30 minutes. And so it seems to be about an hour to an hour and a half.
Are you going to add some sensors, some LiDAR or anything like that?
I figured full self-driving would be a good second project. No, I hadn't thought about that. I did think about maybe trying to do something like face recognition for unlock. And another idea I had for a project is the speed control that I have on there. It does have a serial interface and it's programmable. And I haven't figured out yet exactly like what protocol they're speaking and all that. But if I figured that out, then potentially I could make it so that when my kids are driving, I could basically just like throttle the speed controller and say, hey, you get up to 35% power or whatever. Because I did let them drive it on their own last summer and they promptly crashed it into the back porch. So not great drivers.
So another idea is you can make the speedometer the key. If you're only talking like 20 or 30 minutes, maybe an hour of runtime, you could make an all-inclusive OLED with a little Pi and a little battery pack. And that has the authentication code. And those two talk to each other to both display the speed and authenticate driving the cart, and it's still wireless. Just like magnetic. I don't know what you have in the cart, but wherever you want to put it, just no wires. But with those battery packs, you only get like an hour, I think, out of it.
Yeah. So you're saying interesting. How would I measure? I still need something wired to the battery to get the current state of charge, though, right? But are you saying you would just have the OLED wired into the battery and then it could wirelessly talk to my phone or whatever?
No, I guess I was assuming you already had a little Nerves device on there.
Yeah.
So I thought you had one with the battery, and then whatever you want to display for the OLED is just like a box that has the OLED and a Nerves device behind it and a battery pack to power both of those.
Yeah, and those two would talk. So basically, the like dashboard, like a Scenics project or whatever, it would wirelessly connect to the one that's wired into the battery.
Yeah.
Yeah.
And with battery packs, I mean, on the Raspberry Pi, you're getting an hour or two or something. But if that's all the golf cart's running, and then that also becomes the key. You put a pin on it. I don't know.
Yeah.
Or just
that could be cool. Having
the physical access of it, that's the key to drive it.
Implement CAN bus on my wireless CAN bus on my golf cart.
CAN bus is a nightmare. I've already gone down that road.
Oh, no.
That has been pushed to the side for now.
Stick to distributed Erlang then. From what I can tell, I don't think CAN bus is actually any more secure than distributed Erlang anyway. So
yeah, I wouldn't say CAN bus is secure at all. CAN bus is like blast all the messages all the time. And some of the newer cars have encryption, but a lot of manufacturers publish what structure they use. So it's just overwhelming to deal with when you're trying to reverse engineer.
Yeah.
So Michael, you said you had a speed control, so that replaces the resistors that were on there?
Yeah.
Oh, okay.
Yeah, I left them in there because it's like it's funny, these old, these things from the 1950s. The whole golf cart is heavy as heck, and there's basically no rust on it anywhere. It was really well taken care of, and inside of like where the batteries lived, because the batteries were so enormous when they were lead acid batteries, that my little lithium ion pack takes up like no room at all. And I have tons of extra space in there. So I'm just trying to leave everything alone that I don't need to change. So that if I ever want to change it back, I can, it's still all there.
So the speed control, that's something off the shelf. You could just buy that and just connect it to the accelerator pedal, or
and actually all right, so I'll share it. There's a website called kellycontroller.com, and when I was looking at so I had been looking on YouTube and other things for people who are doing any sort of DIY project with electric mobility, and a lot of people reference this company. So I'll drop a link here into our chat in case anyone else finds this useful. And they have, I wasn't in the mood to like get into all the MOSFETs and everything I would need to do my own controller here, and all the like isolating of those and overcurrent protection and all that. So I used something off the shelf for the speed controller. And then I ordered, just before all the COVID lockdown, I ordered was able to test at that point, like, oh, it's literally just an analog voltage, 0 to 5 volts, gives you the range of throttle response. And so I ordered an accelerator pedal that I could install in the front of the golf cart. And then with everything locked down, the shipping has been very delayed. So I took an old remote control airplane controller and I ran a wire into that and put it across one of the potentiometers that gets used inside a remote control. And that will produce between 0 and 5 volts. So I now, when I'm driving right now with my kids, I have one hand on the steering wheel, and in my lap is a remote control airplane controller, and I use the throttle on that to be the throttle. It's very homemade, made with a lot of love.
Does this have any brakes?
It does still have a physical brake, which
Okay.
was already installed.
Okay, good.
I would love to eventually get like regenerative braking set up. That could be really a fun project, but future work.
Michael, have you heard of the TV show Vintage Voltage on the
No.
Motor Trend Network? Okay. It's all about this place in Wales where they take old cars, like from the 50s, 60s, whatever, and they convert them into electric vehicles. Just reminded me of this, where they get all these Tesla battery packs and stuff.
Yes, that I had not heard about this, but I have a feeling that there's a new binge watch in my future.
Like every episode is exactly the same. It's just a different car, but it's like they're getting the exact same battery packs and the same motor for everyone. But the idea is cool.
Yeah. So maybe not a binge, maybe just 1 or 2 episodes.
Yeah, maybe just find a car that you like.
What's that called again, Todd?
It's called Vintage Voltage. Yeah, I thought it would be cool to get like an old like 65 Continental with the suicide doors. It's got like a 30-foot trunk space. You could probably put a ton of batteries in it.
And they had those. They had humongous motors in those too, so you'd have a lot of space up there too.
Yeah, tons of space up front, tons of space at the back. Maybe get 300-400 miles out of it. But it probably cost like 40 grand to do it. So
yeah,
my stimulus check wasn't that big. So yeah, Yamauchi-san, what were you showing us?
Oh, okay. Oh, this is a toy nervous my application. And dice.
Oh, dice.
yeah.
And Japanese weather forecast.
Random number generator forecast.
Sorry, ちょっと、
Excuse me, ask a question again.
Is the Japanese forecast just a random forecast?
要は日本の天気予報かっていうのを聞いてますね。
Yes, Japanese, my place. Hi. Yes.
This device, tweets as a bot, just periodically, just random some place selected random. Please share the screen in Twitter. 山内さん、ツイッターのスクリーン見せてあげてください。
Okay, so you roll the
共有
dice.
して、画面共有して。
You roll the dice, it picks a location, it gets the weather for that.
見えてますかね、これで。
見えてます。
This is post. This post from Nervous application, Japanese weather forecast every morning.
This morning, this means the island of Yonaguni, the region of Yayama, high pressure and almost sunny. 13th, on 13th, partially covered by high pressure, but gradually cloudy because of なんだろうな、because of moisture. So at night, at locally rainy or thunder with thunder. This Japanese means this forecast. Okay.
Awesome.
Thank you. I use Nervous. I like it.
Yeah.
Modbus. Actually, you use Modbus RTU or in TCP?
Pardon?
Do you use Modbus RTU or Modbus TCP over the network or serial?
要は通信プロトコル何使ってるかって質問ですね。IP なのか、それとも TCP 使ってるのかとか、そういう質問。
I use HTTP Poison.
Okay.
Any other question? Okay. Thank you.
Thank you.
Does anyone else have any projects that they're working on or thinking about?
I do have.
I just got in. Go ahead.
I have two that I could mention. Yeah. Feel free to go ahead. I'd have to grab one off my desk anyway. So yeah, I'll let you go first.
Okay. Yeah, I haven't started on it. I did get the little sensor in, so I'm excited about it. It's just an oximeter and heart rate monitor that I ordered off of Amazon. That I'm hoping to tap into it and just be able to stick my finger on it and compare it to the other devices that do that, but just for fun.
Nice.
I thought that was going to be baby related. I thought you were going to invent something for your baby.
They already have those. But
Reinvent something.
yeah. Yeah.
I'm not sure if I built any sort of electronic device and attached it to a baby, if I'm pretty sure it would be increasing the chances of something going poorly.
Yeah, it's playing with fire a little bit. But you have to remember the people at those professional companies that put this stuff together, they're no smarter than you are, Michael. Don't let all that fancy packaging fool you. And UL listing.
I hope they spent more time on their project than I've spent on mine.
You're very optimistic.
Okay, I'm back with stuff wired up, so hopefully this is a little better. First thing here is this is one of the things we've been playing around with over at the Seattle Elixir Meetup group. So I can't claim credit for thinking of the idea, but I'm kind of helping out with it. And this is contrast is a little bad there, but it's a 12-key keypad. It's a Keybow from Adafruit. It's runs on a Pi Zero out of the box on the back there. By default, though, it doesn't. It comes with its own software running, I believe, Raspbian and all that stuff. So we took that as a challenge of this thing needs to run nerves. Us being the Elixir group, we felt that would be appropriate for it. So we're kind of porting it over to work with that and trying to use it as a platform to be able to get people, kind of more excited and able to jump into hardware without having to go, think up their own project and build their own hardware from scratch and stuff like that. So we've got a big web following in the group, just kind of due to the nature of the area. So we're trying to convert some of those web people over into the hardware world if we can. And the guy who kind of came up with the idea for this, Chris Dose, loves building mechanical keyboards and stuff like that himself. So this that was something that inspired him around this, and you probably can't quite see some of those patterns, but maybe that one's a little better. So it's got various animations you can run through. So we want people to be able to extend those out and kind of build their own animations to this, as well as being able to configure the keypad for sending keyboard commands out to the computer, or macros, or even building little standalone games in it. So if you wanted to run it separate from the computer, you could do a little Simple Simon game, or Game of Life or something like that with it. So interesting little possibilities there. Let me this is still really, really early, but I can link the GitHub repo for anyone who's interested in taking a look at that. So there's that one. The other thing that I've been playing around with, I'll just share some screenshots of this, because this is another crazy project. So I have done a virtual cockpit setup with Powered by Nerves right now. So basically the hardware on the left-hand side here is being driven by a Nerves controller. And if I go, let's see, I have another close-up shot here somewhere. Here we go. So the community, kind of the flight sim community, has a following around integrating this stuff with Arduino, and of course that's no good because I want to program it in Elixir, right? So I had to switch it over to Nerves. So I'm running it on the BeagleBone Black there, and this is very, very early prototyping right now, but it's actually working, which is cool. So inside the sim, I can actually flip the switches and they actually do stuff in the sim. And so that's really fun to be able to use that. The rat's nest of wires here, of course, needs to be converted over to shift registers and stuff that's more manageable. But for now, it's up and running and it works. So it was pretty fun and pretty cool to do this. And I, of course, need to expand it out a little bit. But yeah, I'm kind of trying to come up with some of these inspiring things that, this is obviously just a bunch of GPIO now. So it's right now, so it's really easy for for kind of like an entry-level project for somebody to get into, but it looks impressive. Like it looks a lot more impressive than the code is. So I'm trying to use these types of things to show off to people who who are interested in hardware but haven't quite stepped into it yet. And basically, I want to lure more people into our community. So I'm trying to find inspiring ways to do that.
Clickbait projects.
Exactly.
That's amazing. I would love, what's the connection between the BeagleBone Black and the computer that's running the simulator?
That is, oh man, you're gonna make me give the talk all over again. Let me get back to the slide share. That's a program called DCS BIOS. And so they've got this web interface that basically works as like a plug-in between the simulator and hardware that you want to connect to it. It's got a couple ways that you can get the data in and out of it once you're in hardware land. So you can do it via serial port, which of course is how most of the Arduino stuff does it. They also support Ethernet through TCP or UDP. The way they integrated with this, you kind of do need to make some conscious choices about which one you use. Unfortunately, it's not as simple as your traditional like layer 4 networking choices of why you would use one versus the other. They will only give you like they will only push you data out of via TCP. So to be able to like control any of the lights or any of the indicators, to get feedback for that, you have to be using TCP for that. So, but whatever, both are easy to get to in Elixir, so not too much of a disadvantage. One cool part about this is they give you code snippets, but the big downside is, of course, they're code snippets to copy paste into Arduino, which is one of my other personal pain points around this. Is it seems like to cobble this together in an Arduino project, you're kind of copy pasting what becomes a bunch of spaghetti code, and hopefully I'd like to be able to like abstract some kind of library that makes it better or more friendly to work with this kind of thing rather than just the copy paste route that they've got going right now. But I think that's kind of an Arduino community thing. So I can't hate on them for that. I can just hope to improve it on the on the Elixir side.
Oh man, that's amazing. And you mentioned shift registers. I've heard the term, never done it. I would love, maybe this is a future meetup idea or something, but I would love just to get ideas on, oh man, there it is. You had this whole talk is like written for me.
I'm gonna have to redo this talk sometime, aren't I? So yeah, basically the short answer of this is, so when you're connecting with the GPIO ports, you're making a one-to-one connection from your switch, from your LED, whatever, directly to an IO pin on your device. Uh-huh. This is nice with the BeagleBone for like how many switches and things that I have to control on this, because like you saw, rat's nest of wire plugged into these header ports was great. If this were on a Raspberry Pi, I would have easily run out of header ports, pins to be able to plug stuff into by now. But regardless of that, if you can wire all this stuff into shift registers. This is actually the wrong model number of register for inputs. This is the one for outputs. So don't do what I did on the drawing or your project will not work. But the short answer of what this does is you can consolidate all of your wiring down into a much simpler interface for getting back into your hardware. So each one of these input devices, for example, wires up to a pin on the shift registers. You can cascade your shift registers together just by looping the input of one register to the output of the other. And then you can bring them back into your actual hardware with about 3 wires. So you have like a clock signal, a data signal to be able to shift your data in or or out of your actual hardware, and the other one is a latch signal. So it'll trigger when this actually captures the high or low signal of the switch. So you trigger the latch and clock your data either in or out of the registers. Really cool thing about this is it's directly compatible typically just to wire it into your SPI IO as well, because it basically works electrically the same way that SPI naturally does. So that's a cool and fast way to be able to get that in without having to write your own bit flipping code to flip all these pins yourself.
Yeah.
That being said, there's only 3 pins, so you could totally flip them all yourself if you wanted to.
That is amazing. What a fun project.
Yeah, this is a fun one.
Yeah, thanks for going over shift registers like that. That's been kind of something that I've wondered about, how people take in like a lot of inputs onto these devices. So it's cool.
And you mentioned that's totally doable for output as well.
Yeah, so there's 2 different, well, there's several models of shift registers, but basically they will either shift data from your like IO ports in, or they will shift data from your hardware back out the ports. So just based on the model number, you can kind of look them up on DigiKey, but 595 is the common output shift register. The common input one escapes my mind, but if you Google it, it'll pop up.
How many of those can you daisy chain?
As far as I know, basically as many as you want. The constraint is like your electrical constraints. So how much noise is on the line, for example. So if you daisy chain like, and also your clock rate. So the more that how do I explain this? The longer that your signal path takes, or essentially like the more capacitance in your signal path, the slower you have to clock. So if you were trying to run this thing like 10 feet, I don't know why you'd have 10 feet of these chained together, but if you did, you're going to have to clock at a much slower rate to be able to get a reliable data signal back than if it's, if you've got like a couple inches, of space or less that you're trying to go through. So there's a lot of trade-offs, but all these things run like really fast these days. We don't have the problem of like clock slew and all that fun stuff with like low speed devices like they did, like in the 70s and stuff when these came out. So if you're running, at like your typical serial speeds, like 115, 200 or something like that, or you're running these at like 1 megabit per second, for most of the stuff you're doing, if you're connected pretty close to your controller, you're probably going to be fine. Or at least I haven't had any problems with it so far. If you really want to know spec, like they all come with different specs. They have different like, I don't want to call it qualities of chip, but kind of like variants of chip. So if you need like a chip that supports higher speeds, like higher data rates, you can get those. They're of course a little more expensive, but they've got kind of like different variations of, say, like the 595 line of output registers that you could choose from. Same thing with the inputs and all that.
Yeah, I in my last house I made my own home sprinkler, and I haven't done it since I moved houses because there's too many zones and I don't have enough GPIO, and I really didn't want to like daisy chain Raspberry Pi devices or something.
Oh yeah.
So
yeah, there you go.
This is 100% up in that use case.
It'll be significantly cheaper as IO expansion to do that too. There's kind of an example of me prototyping a chain of shift registers to be able to replace the current IO so I can wire them in to the board. So here's the line, one of the single lines that just needs to go back to the actual BeagleBone Black controller. I haven't broken out the other 2 that I need yet. But then most of the pins down here that are unused, that's where all those switches and stuff will plug into. And then of course I'll convert that to a proper circuit board at some point, but I want to make sure the prototype works first. So yeah, that's the crazy stuff I've been up to.
That's pretty awesome. Thanks.
You're welcome.
All right. Go ahead, John.
Oh, I was going to say, it's funny you're talking about the Arduino code and people taking it, because I've been working on bridging the NERSC Arduino relationship, because, well, it started out as I've got these little IR modules or IR transceivers. I wanted to replace the remotes in my house because I'm sick of losing them and my kids losing them, but I don't want to put I just wanted to use little Arduino drop-ins and just like tape to the back of the TV. But I want to manage it like I manage nerves. So I actually have been working with ESP modules and getting them connected to Nerves Hub and trying to be able to write firmware in an AB partition on 4 megabytes of space from my Nerves device or from Nerves Hub. And to just have like a snippet of Arduino code that you want a little module, you want to put a little stuff on and have do remote firmware updates, boom, just paste this code in there.
Maybe is that how you're planning to convert the whole Arduino community into Nerves people? Is like give them their first over there updates and then be like, by the way, if you want to do other cool stuff in your project.
Yeah, sure. there exist Arduino OTA updates, I believe. Like there are libraries to interface with it, but you've got to like set it up and run it all by yourself. This was just more of like, can I do it? The answer is mostly.
These little devices aren't exactly cheap, but if you want to be lazy with IR, this will do IR capture and replay, and it's got a network interface port, so you could basically turn like your Nerves device into kind of like a remote controller or whatever. You know, it can do your control that you want it to do, and offload the IR portion, to something like this. If you'd rather spend the money versus going the Arduino route, but if you want to play with Arduino, then this is not a good option. So just whichever way you want to go.
It was like, I've got all these ESP32s for $2 each. And
nice. Got to put them to use.
You know, it's so much cheaper. Just put a little IR LED on it. All Nerves will be the brain to tell it what to do from my phone and my already existing home setup. But yeah, the IR portion is actually not that hard. I've been working on a port of some other libraries. And in fact, Matt's not here tonight, but Matt Ludwigs has been working on switching circuits GPIO to use chardev instead of sysGPIO. And chardev gives you a much greater speed enhancement into detecting shifts on the GPIO pin, which means that we could do that pulse, that duty cycle calculation and do IR straight from Elixir to determine the codes. So I have an example with the current GPIO decoding IR signals in pure Elixir, but it's not quick enough to transmit it back out.
Gotcha.
On a GPIO line.
The other thing that BeagleBone has, I haven't played with this through Nerves yet, but it's got 2 PRUs, programmable runtime units, and they're like 2 little 8-bit processors built into the chip that you can get to, essentially from the operating system. I haven't played around with like compiling code and accessing those yet. I think somebody has built the Nerves library to do that, if I remember right. But that might be another way to get that like processing mechanism and stuff like that to work correctly if you're having trouble, with like the speed coming in, through Nerves and through the OS and through that route.
Yeah, it's not bad. The ported library stuff, that works. I just don't want to manage ported Python code.
Gotcha. Fair enough.
I just want to easily do it. Well, not easily, but
I want to
do it in Elixir.
ESP devices to Nerves Hub.
No, that was a total yak shave. Like I started out with the day connecting an IR LED and ended with getting this to work with Nerves Hub.
Have you had any problems with the variations in IR protocols? Like some of them have like the A and B pattern that they have to repeat in that order and stuff like that?
So using the ports and using the Arduino libraries, they handle a ton of that. There's a couple IR libs that go through tons of different variations. Like Samsung, for whatever reason, always has to do their own thing, like always. So there's the generic IR, what everyone else uses, and then Samsung does the reverse, and the A, I don't remember at the end. Anyway, it's like total backwards, and they handle that. So most of the time, I don't even worry about that. Also, all the remotes that I have are pretty generic and come through the generic encoding. So
Nice.
not an issue I've run into yet, luckily.
So those PRUs, are those basically then kind of like coprocessors? It's kind of like having an embedded. Well, I guess you're sharing a bunch of the hardware between the two, right?
You're sharing pins. But you're getting basically two Arduinos, if you will, inside that ARM Cetera chip that powers the BeagleBone. So they are actually dedicated portions of the silicon that are two little 8-bit microcontrollers, if I remember right, that you get access to. And they do run separately from the main processor. So you can use those for like your more real-time looping that like the Linux side of things might be too slow for.
Yeah, that's a really cool idea because kind of like the idea of the muon trap library that has come out of the nerves community. You would, instead of like shelling out to some operating system command, kind of at boot time, you could just like send the opcode that you need to that PRU, and then figure out some sort of collaboration mechanism between the two. So the PRUs then would have access to pins. You're going to have to just know which pins are being controlled by which of these two actors.
Yes, and luckily you can control that with pin muxing, so you can set up which pins do what. And there's also a bridge you can set up. I don't remember exactly how this works without going back to the documentation, but there's some way you can set up a bridge to get data between the main processor and those PRUs as well, without like having to go out your physical pins and back end.
Yeah, that's really cool.
Yeah, that's on my wish list to play with, but I haven't gotten there yet.
Oh man, well, now I have a really good reason to go buy BeagleBone Black.
I love the thing. It's basically my go-to hardware at this point. I've still got it, I've still got the Raspberry Pi and the Pi Zero and all that stuff, of course, because you just kind of have to have all those. But I'm really loving development on the BeagleBone.
Yeah, I gave away the secret the other day I was working on that project, and I wasn't getting a voltage reading that I thought. I went to switch two wires and confused which was my 5-volt wire and which was my 40-volt wire, fried a Raspberry Pi Zero, which I was kind of surprised I went this long without having bricked any of my Raspberry Pis before. And so my wife was like, "Oh, what's wrong?" Because I was like, "Dang it." And I was like, "Oh, I fried my board." And then later in the day, I had it working again. And she's like, "Wait, how's that working?" And I was like, "Oh, I put one of the other Raspberry Pis into the project." And she's like, "How many of those things do you have?" And then I was like, I kind of feel like this, can I take like the 5th at this point? I feel like this is self-incrimination if I answer honestly.
Yeah, I
was looking for one for this project, and I realized that I have 4 in my toolbox. And then I just found another one the other night that was up in my nightstand.
When John and I used to work at the same company a while ago now, it's been, but there was like this thing where you could nominate other engineers who you had seen do excellent work, and we had this box O swag, and so it was like t-shirt, like nerdy t-shirts and stuff, and there was Raspberry Pis. It was amazing that like every week people would take the Raspberry Pis, whoever won it that week. It was just like, we bought all this other stuff trying to think of like clever things that people might want, and people would just take all the Raspberry Pis.
Yeah, I'm pretty sure that's where I got most of mine. It's from the years of Boxo swag.
Yep.
Also, I wanted to say I'm pretty sure that the Pocket Beagle also has PRU.
Yeah, I believe it's
at least one of the PRUs, because it's the same Octavo chip.
Mm-hmm.
Sorry, I'm looking at mine right here. Pocket Beagle's like the Raspberry Pi Zero. It's just a smaller version of a flagship product.
Yeah, I believe you're right. I recently picked up the Pocket Beagle. Haven't had a lot of time to play with it yet, but I believe you're right if I remember correctly. It's basically the same, not microcontroller, the other thing.
It's the same processor.
Yeah.
It's the same Octavo processor.
Yep. And so you get all that stuff. It's just a different pin count and smaller profile, I believe.
Mm-hmm.
Apparently there is a Pocket Beagle dog breed, so just searching that doesn't give you the Beagle bloom.
Well, anyone in the group is welcome to present on either one of those topics. I would vote for those. All right. Well, are there any other projects? I know we're pretty close to usually the time that we wrap things up. And I don't want to drag this out if we're kind of done for the night, but any last projects or topics that people are interested in for the future? All right. Well, I guess that's the natural time to close this out for tonight. Zaki, it was great to have you here. Yamauchi-san, also great to have you, and thank you for sharing your project with all of us. Thank you to everyone else for being here, and as always, it's a joy for me to be able to share my love for these kinds of projects with a group of people who understand it a little more than most of the people who are physically close to me in my life. So thanks for being here, for sharing projects and ideas, and we will hopefully get the right Zoom link posted further in advance of next month's. We had no trolls this time though, so progress,
Yeah.
you know, iterative progress.
Yeah.
All right, we'll see everybody.
All right. Yep. Thank
Hi,
you.
everybody.
Bye,
See you
everyone.
next month. Bye.
Thank you.
Thank you.
Thank you.
Bye.
Bye.